Here's another problem from section 4.7, the section that's on L'Hopital's rule. Here we have a limit as x goes to infinity of something that's very fraction-y and has an e to the power in it. And if we set this up ready for L'Hopital's rule, we would let f of x be the numerator here, and g of x be the denominator. And if we look, we can see that the limit as x goes to infinity of g of x, so 18 over x, is equal to 0. This is an example where we have a constant numerator 18 and a denominator that's going to infinity. So whenever we have a constant divided by something that's getting larger without bound, that quotient is going to 0. In the numerator, we also have the limit as x goes to infinity of the function. And in this case, again, the 18 over x, we already said was going to 0. So now I just got to trace my way back. This term's going to 0. So this term is getting close to e to the 0, which is 1. And so this term is getting close to 1 minus 1, which is 0. So I can work my way from the inside out. But the point here is that the numerator and denominator are both going to 0, which means that I do have my 0 over 0 form. Remember we said that was one of the indeterminate forms. The other one is when we have something going to infinity divided by something going to infinity. So that means the L'Hopital's rule applies. L'Hopital's rule means that we need to calculate derivatives. The derivative, maybe I'll do g prime first. The derivative of g, this is 18 over x, which means it's really 18x to the minus 1. So I'll put that in parentheses there to remind myself. So that means the derivative of 18x to the minus 1 is just the power rule. The negative 1 comes down, and we have negative 18, and then we have x to the minus 2, because minus 2 is 1 less than minus 1. So the derivative of g of x is negative 18x to the minus 2. The derivative of f of x requires the chain rule, but the chain rule is very simple when you have e to a power. The derivative of e to a power, remember, if I have e to some kind of hairy mess, the derivative of that is just exactly the same power of e times the derivative of whatever that power of e is. For f of x, that means that my derivative of e to the 18 over x is e to the 18 over x times the derivative of 18 over x. And of course, the derivative of minus 1 is just 0. Notice, though, that the derivative of 18 over x is exactly this same thing. So we're going to get a very nice cancellation here. The limit as x goes to infinity of f prime divided by g prime is going to have this e to the 18 over x in it times the derivative of 18 over x, which we've already done once, divided by the derivative of 18 over x. And so this is a clean break. The one factor in the numerator cancels with the entire denominator. So I have, I forgot my limit here. Limit as x goes to infinity of just e to the 18 over x. And just as we said before, the 18 over x part is going to 0. So e to something going to 0 is getting closer to e to the 0, which is 1. So we're using L'Hopital's rule, and we have to remember to use the chain rule when we take the derivatives. Other than that, this is a pretty typical problem of a quotient that has 0 over 0 indeterminate form.